Okay, so this presentation is going to deal with scales, units, and symbols. So we'll first start out by talking about scales. So here we have the world, courtesy of the Google machine. You can see North America, Europe, all the other different continents because we're zoomed out very far. In the bottom right of the screen, you'll see that Google has provided a scale for us so we could determine the distance between things. So for this image, it's saying this distance is equivalent to 2,000 miles. On my 27-inch monitor, it's about 2 inches. On your TV screen, it may be 4 or 6 or something along those lines. Or if you're on your phone, it'll end up being smaller if you were to hold a ruler up to it. Now, whatever you're watching on, me with my monitor, TV, phone, whatever, we are taking up the exact same real estate on the screen. But now we are zoomed in to only America. And as you could see on the bottom right, the scale may have adjusted very smallly, but it's still roughly, for me, 2 inches and you whatever. You could see that that scale went down. It was originally 2,000 miles and now it's 500 miles. And if we continue to zoom in to, say, New Jersey, it's now only 20 miles for around that. And then if you zoom into like a house in New Jersey, it's about 200 feet. And I don't mind putting this on the YouTube because I no longer live in that house. But the main point that I want to get across here is that it's fairly worthless unless there's it's fairly worthless to have a drawing unless there's an accurate scale on it. All of these pictures were the exact same size on whatever screen you were viewing it on, but the scope that they were covering was drastically different. We could have something that's the world, or we could have an overview of a house, or we could have like a phone detail. If you don't provide that scale, your drawing's worthless because nobody could actually recreate it. So there are 4 different main scale types. There's numerical, graphical, verbal, and CAD. Numerical can be broken up into subcategories, which we're going to go through, which is like representative fraction, metric, civil engineering, architectural. I've never heard of a verbal scale before this class, and I had to Google it. And it's apparently a thing, specifically if you do GIS. So I kind of felt dumb after that because I was going to make a joke, but we're mainly just going to talk about the numerical and graphical in this presentation because it's the only ones you're mainly going to deal with. So the first numerical scale we'll touch on is a representative fraction. So a representative fraction is a map scale where figures representing units are expressed in the form of a fraction or a ratio to indicate that 1 unit on a map, so you have 1 unit on a map, represents X units on Earth's surface. Some examples of a scale would be, say, 1 to 1. Like you could see in the thing it says 1 to X. You could have 1 to 1, which will be like a small object. Your assignment 2 will likely be scaled to a 1 to 1 scale. 1 to 100 would be something similar to like a floor plan. 1 to 24,000, which is 1 inch equals 2,000 feet. That would be like a larger project. Or if we go back to our world map, that would be like a 1 to a million scale. Metric scale is very similar to a representative fraction. So, in fact, the first one that I have listed here is technically a representative fraction. It's 1 to x. The other form is x to 1, and it's simply the ratio of a unit on a map to the unit on Earth. It's similar to last slide. If you were to say 1 to 100, the thing with metric scales is it could mean 1 centimeter on a map is equivalent to 1 centimeter on Earth, or it could be 1 inch on a map is equivalent to 100 inches on a map, or a mile is equivalent to miles. So this table kind of gives you some common map scales and their equivalents. So if we were talking to, say, a 1 to 250,000 map scale, that's approximately equivalent to saying 1 inch is about 4 miles, or 1 centimeter is approximately 2.5 kilometers. After metric, we have civil engineering and architectural scale. So they're both displayed here. Civil engineering scale is given by the form 1 inch equals X number of feet. So I have some examples there. We have 1 inch equals 10 feet, 1 inch equals 50 feet. In terms of this class, I don't want you to be giving me what I would call stupid scales. Like, what's the point of giving me a scale that's 1 inch equals 104 feet? Make it 1 inch equals 100 feet, or if you need to go bigger, maybe like 110, 125. Don't do 104. That's stupid to me. Typically, in terms of civil engineering scales, I'll do 1 inch equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 feet, and then I may go up by like 5, so like 10, 15, 20, 25, 30, so on and so forth. You kind of get a feel for what seems reasonable. Architectural scale is something that you would generally find on a ruler. So that's given by the form X number of inches is equivalent to 1 foot, and specifically 1'(-0 inches, so quotation mark. So that's the specific form. In terms of both of these, if you don't put them in that form, you will get points taken off in my class. It's not hard to do. Generally, if you just use the ones that are predefined in AutoCAD and type it exactly as it says, you'll be good. Don't forget the dashes, don't forget the equals, don't combine the two different ones. But as I said, an architectural scale is something that you should generally find on a ruler. So we're talking about halves, quarters, eighths, sixteenths. So if you were thinking about in terms of civil engineering scale, you may think that 1/10 inch is something that's good. It's like tenths. Tens are good ones. No. In terms of this, an architectural scale is something you find on a ruler. You don't find tenths unless it's a special kind of scale. So we want stuff that you would find. So 16ths, 32nds, stuff like that. I have this slide here mainly so you could reference it when you're making your drawings. These are typical scales of drawings you may have to do. So if you notice when you go to your viewport and you create your scale and your scale is not even close to what these are saying, you may have done something wrong. And the most common explanation for what somebody may have done is, say you're using engineering units, which means if you type in 10 enter, it defaults to 10 inches. But say you wanted to make it 10 feet and you're like, oh, I'm in engineering units, I push 10 enter, that's 10 feet. No, it defaults to inches. For 10 feet, you would have had to push 10', which would have been 10 feet. So your drawing, even though it may look good, is going to be off by a factor of 12. So that's why I have this here, because if you notice that when you scale your drawing in your viewport and it's completely off, you jack something up. I'm not sure specifically what it is. That's the most common thing that happens. But when you do your floor plan, if it's not somewhere between like 1/4 and 1/16 of an inch equals a foot, I double check some stuff. Generally, you could just go into the properties of a specific line and just see what it says. If you meant to make something 20 feet and it ends up saying like 1.75 feet, that's because it's off by a factor of 12. So what if we wanted to convert between different types of scales? It's fairly simple dimensional analysis. These first examples are going to go from a civil engineering scale to metric. So if you were given 1 inch equals 20 feet, all you have to do is convert the right side of that equation to inches. So you're converting your 20 feet into inches, which is just 20 times 12, 240. So in terms of a metric scale, that would be 1:240. So I'm going to leave this one up here for a few seconds. If you want to pause the video, you could try it yourself to get the concept down. We're doing the same thing. We're going from 1 inch equals 500 feet to a metric scale. And all you would end up doing is, again, that right side you'll times by 12 because we're converting to inches. So 1 inch will be equivalent to 6,000 inches, which would just be 1:6,000. Remember, if you're using a metric scale, you're not putting any units on it. So that's another common mistake between, say, the civil engineering scales. You may end up saying 1 equals 240. You're mashing up either the architectural and civil with the metric. Metric has a colon. So this next one's going to be going from architectural to metric. So this one essentially just has an extra step in it. So the first thing you're going to want to do in terms of this one is make the left side into 1 inch. So you're going to times both sides in this first example by 16. So you'll be left with 1 inch equals 16 feet. And then we just do the exact same thing we did on the last slide, which is going to be changing that 16 feet from feet to inches. So you'll have 1 inch is equivalent to 16 times 12, which is 192 inches, which is a metric scale of 1 to 192. So similar to last time, if you want to pause it and try it yourself, here is a few seconds, and we're going to do 1/4 inch equals 1 foot, and we are going to convert that to a metric scale. If you follow the same process, it's going to be 1 to 48, because we're going to times by 4, and then we're going to times by 12. So now we're going to go backwards from the metric to the civil engineering scale. If you were given a metric scale of 1 to 24, the easiest way to do this is just to assume both sides are in inches. So we're saying 1 inch to 24 inches. And then we just go the reverse way. That 24 inches we're going to make into feet, because if we go back to this slide, the general form of civil engineering scale is 1 inch equals X number of feet. So we need to get it into that form. 1 inch equals so many feet. So if we have this one, we're going to convert that 24 inches into feet, and you're given 1 inch equals 2 feet. So as with the previous two examples, I'll give a few seconds if you want to pause and try it out. So for this one, again, assume both sides are in inches, 1 inch to 3,600 inches. We're going to convert that 3,600 inches to feet. So we're given 1 inch equals 300 feet. It's fairly simple stuff. So if we want to go from metric to architectural, we're doing a similar process. So again, assume both sides are in inches. So you're given 1 inch equals 8 feet. However, there's a reason this is wrong. And I generally like to go to the class and be like, oh, it's 1 inch equals 8 feet, right? And everybody's like, yeah. But since this is a presentation, I don't get to have that reaction. The reason this is wrong is because of the form we need to put it in. So if we go back to the architectural scale, it's X inches equals 1 foot. So we need to get that right side into 1 foot. So if we come over here, the reason this is wrong is because that right side is not into that form of 1 foot. This would need to be 1/8 of an inch equals 1 foot. And this makes sense too, being an architectural scale, that it's some units you find on a ruler. So if you wanted to try this next one, 1 to 384, give you a few seconds to pause and try it. So the right side, divide by 12, you got 32 feet. You're then going to have to divide both sides by 32. So you're left with 1 foot on the right side. So you got a 32nd of an inch equals 1 foot as your architectural scale. So now moving on to graphic scales. If you're given a map, there's likely going to be a graphic scale on it. For these two, they're generally giving at the bottom. So those. They're just like representative fractions in that they relate a distance on a map to the distance on Earth. So being in America, we often will calculate or convert stuff to an inch. To go between representative fractions and graphic scales or vice versa is pretty straightforward. If you are given a representative fraction of 1 to 250,000, which actually we kind of talked about earlier, that's essentially saying 1 inch on a map is equivalent to 250,000 inches on Earth. So if we were to convert that 250,000 inches back, that's roughly saying 1 inch on that graphical scale is equivalent to 4 miles. And that's nice if you have a map and you're trying to orient yourself with where it's at. Now, if you wanted to go from graphic to representative fraction, say you were giving 1 inch equals 5 miles. You just convert that 5 miles to inches with some dimensional analysis, and that ends up calculating out to 1 to 316,800. Again, fairly straightforward stuff. CAD scales. AutoCAD models are created at a 1-to-1 scale, and scales are generally applied when printing. In terms of most sheet sets that I've seen, when you print stuff out, you typically want your text to be around 1/8 of an inch and your titles to be around 1/4 of an inch. For the early portions of our assignments, you're just going to manually change the text heights or the letter size, the arrow sizes. But in one of these videos, I will go over annotative scaling, which is a useful tool for later on, that it'll automatically do it for you. So in terms of your earlier assignments, let's go with like a Goldilocks principle, where we want something that's not obnoxious. So if you're looking at that picture, the one on the left is obnoxious on the small sense, you can't read it. The one on the right is obnoxious on the big sense, because it's just super large and unnecessary. The one on top is just right. So let's apply a Goldilocks principle when doing our original drawings. So AutoCAD allows you to work in 5 different length types. So if you were to go into AutoCAD in your model space and you just typed in units, you're going to get this dialog box on the left to pop up. If you're using the title block iSet, it's going to be in engineering already. I would advise typically just working in engineering. So if you were to type in L enter for line and then 10 enter, it's going to assume 10 inches. Or if you type in 10 apostrophe, it's going to be 10 feet. It's going to be stuff you're used to working with. But there are other length types out there. You have architectural, decimal, engineering, fractional, and scientific. So for decimal and scientific, it doesn't assume a unit. For architectural, engineering, fractional, it assumes inches. So, like I said, in this class, we're generally just going to deal with engineering. Depending on the assignment, your angle, you may change to surveying units. But for now, if you just use decimal degrees, that's fine. One thing to note, that insertion scale only deals with blocks. So if you change that to feet, it's not going to be when you push 10 enter that it's assuming it's 10 feet. That's not what that is. This is for anything that's inserted into your model space. So you could disregard that for now. You only have to deal with those top 2 ones. Finally, on the symbols. Symbols are used on maps to keep information on the map to a minimum by minimizing text and simplifying the drawing. So if you had some road project, like you got a lot of crap going on. So the way it's easier to read is by decluttering your images or your drawing overall. So a lot of times these symbols will be used to represent things. So you'll have a legend and it'll be like, this line type means this, or this symbol means that. So here's just some examples of symbols and line types and stuff like that. And it's mainly used to help declutter a map so you can find things quickly and easily. And we're talking about symbols. We may also be talking about blocks. In AutoCAD, you can import in a whole bunch of blocks that are already drawn. So you'll use this for your floor plan assignment. And I went over this in the assignments YouTube. So if you fast forward to the floor plan assignment portion of that presentation, it shows you how to get to this list. But there's a design center in AutoCAD, and if you type in AD Center for AutoCAD Design Center, you go through a couple of prompts and you could find all these different blocks that you could insert into your drawing. Now, you could also create your own blocks if you want. So if you were to create some image and you want to like save it as a block, you could use the W block command to where then you could select your object using that, and the bottom arrow is just saying where you would save it. And then afterwards, you would just insert your block by browsing. It's pretty simple. So there's some references. That's going to be the end of this presentation. I got one more presentation left, so we're getting there.